Hello everyone, how are you all? I hope you all are fine. This is your chemistry lecture of grade 10th, and I am your chemistry teacher Aparna Pandey from Art and Progressive School, Lamachor. So student, as you all know that in chemistry here we are discussing our chapter number 1, and in previous parts of this chapter I have explained you what is chemical equation, what is chemical reaction, what are the changes that we observe during a chemical reaction, and I have also explained you several activities where we have noticed the changes, right? Now student, in today's video I will explain you about the types of chemical reaction. Though in our previous video I have explained you about two types, that is combination reaction and decomposition reaction. So student, in today's video first we will revise what is combination reaction, what is decomposition reaction fast, and then we will move to the next type of reaction. Okay, so for a revision, just you can go through this. What I have written here, chapter number 1, chemical reactions and equations, and the topic is types of chemical reaction. So in this types of chemical reaction, first here we are going to discuss about the combination reaction. We are going to discuss about the combination reaction. Now when we talk about the combination reaction, students, I have explained you, and I hope that now you all are clear about the combination reaction, that what happens in this case. In this case, what I told you, suppose we have taken two reactants. Suppose we have A and B as a reactant, and when we in the combination reaction, what happens that when we combine these two reactants, we are getting one single product. We are getting one single product in a form of AB, right? Where these two A and B are the reactant. A and B are the reactant and AB is the product, right? AB is the product. This I have explained to you in previous video. Okay, so itna I hope it is clear to everyone that in combination reaction we have the two reactants or more than two which are combining together and forming one single product. That's why the type of a reaction is called combination reaction. For example, it may be, if we notice the examples of the combination reaction, then what we will come to know, examples. If we will notice the examples, then we will see that suppose we have, yes, Mg plus O2, then it gets changes into MgO, or you can say 2Mg plus O2 get changes into 2MgO. So here what we can see that we have taken two reactants, and when these two reactants combine with each other, they are forming one single product. Okay, so this is the example of combination reaction. Similarly, we will have even more example that we can take of water. So 2H2. Okay, here I am writing AB, either it will become confusing quite. Okay, so B1 is 2H2 plus O2 get changes into 2H2O. So again here you can see that we have taken two reactant and we are getting one single product. So this is also the example of the combination reaction. Similarly, suppose we have C plus O2, then it gets changes into CO2. This is also the example of the combination reaction, where this is also the example of combination reaction where two reactants are combining with each other to form a single product, right? Some more examples we have. Suppose this we can take Fe plus S. So it gets changed into ferrous sulfide, Fe and S. So these are are the examples of combination reaction where we come to know that when we combine two or more than two reactant, we are getting one single product, and this is only the combination reaction. Okay, so here the first type of the reaction, that is combination reaction, we have done. Previously I have explained, right now I have just given you the revision of this. Now let's move to the second type, that is I told you decomposition reaction. Second type of reaction is our decomposition reaction. Okay, decomposition reaction. Decomposition reaction. Now student, as the name suggests, I hope you all know what happens in case of decomposition reaction. Decompose means the splitting up. Decompose means the splitting up or the breakdown. So when we are talking about the decomposition reaction, then I have told you earlier, here the single compound splits up into two or more compound, or we can say two or more element or anything. Means but the decomposition takes place. Decomposition means breakdown. So for this, suppose here we have taken AB. AB is one single reactant or compound which when undergoes decomposition, that splits up into A plus B. Okay. So what is this? This is the decomposition, or we can say suppose we have any compound A, B, C. So when it undergoes decomposition, it breaks down into A plus B plus C. So here what we can see that we have seen that when we have taken a reactant, it gets splits up into two or more than two products, and this is called decomposition reaction. Now, in case of decomposition reaction, I hope that you all have remembered I told you when we have to break something, then definitely we have to provide some extra energy for that, right? We have to provide some extra effort. We have to do some extra effort so that we can carry out the reaction. So when we talk about the decomposition reaction, students, it is of different types, and the types depend upon that how decomposition has taken place. Suppose the decomposition has taken place in the presence of heat, then we say that it is a thermal decomposition. Thermal means heat. When we have provided heat and then the breakdown of the reactant took place, so it means that this type of decomposition is called thermal decomposition. Suppose we have applied current, so then what we will say, it is an electrolytic decomposition or electrolysis, where we have done breakdown by passing current. Similarly, if the breakdown has taken place in the presence of the sunlight, then what we will say, that photolysis has taken place. What is this photolysis? Photo means light and lysis means breakdown. So when the breakdown takes place in presence of light, then it is called photolysis. So these all things depend upon the type of reaction that is taking place. For example, earlier also I have explained you the example of silver chloride. Okay, so there what I have told you, yes, the example of, suppose I have taken the example of silver chloride, so AgCl. Now what is this AgCl? This is silver chloride. When this takes place in presence, so when it is kept in presence of sunlight, so silver chloride loses its original property and it gets break down into Ag plus Cl2. It breaks down into Ag plus Cl2. What is this? This is the breakdown of the single compound into two. So what is this? This is a single reactant which is decomposed into two parts, Ag and Cl, and when we will balance it, so what we will get? At the time of balancing, we will get it like 2 Ag and Cl2. So now it is balanced, right? So in this way we can conduct this reaction. Now students, you can see here for carrying out this reaction I have provided sunlight. Means for carrying out this type of decomposition sunlight must be there, or we can say in the presence of sunlight silver chloride breaks down into the silver and chloride, right? Another thing is that here I have written sunlight. This we can write like this also, photon. We can represent it like this. So H nu, where it is written, it means that it is sunlight. And this type of breakdown is called photolysis because it is taken place in the presence of light. Now, second example we can take of breakdown is that, yes, we have like this. Yes, the most simple, H2O get breakdown into 2H2 plus O2. What it is? This is also the decomposition only. How? Because here again we have one single reactant and it gets splits up into the two products. As I have said here that for decomposition we must have a single reactant which gets splits up into two or more than two products, right? So this is our decomposition reaction. Now in decomposition reaction, what happens here also, as I told, we have to put some special effort. So for decomposition reaction of this one, what we need to provide current. We need to provide electricity. So this is called electrolytic dissociation or electrolytic decomposition. Okay, this in the presence of electricity. Okay. Now, when we see in this way, there is the different types of decomposition depending upon the condition that we have applied. Like first one is photolysis, second one is electrolysis, then one more I have, this is also the common, CaCO3, calcium carbonate we have taken. Now, how we will do the breakdown of this calcium carbonate? So, for breaking this calcium carbonate, what we have to do, that we have to provide heat. When we will provide heat, this CaCO3 will get breakdown into CaO and CO2. CaO and CO2. So what it is? CaCO3 is our calcium carbonate, and when we have provided heat, it gets breakdown into CaO and CO2. So what is this? This is the decomposition which is taken place in presence of heat, and this is called thermal decomposition, So here what we have seen, that when we have taken calcium carbonate, after providing heat or after doing thermal decomposition, this calcium carbonate breaks down into calcium oxide and carbon dioxide, CaO and CO2. So in this way the decomposition reaction takes place by providing special efforts. Okay. Now let's see another type of the reaction, that is, the third type of the reaction is displacement reaction. Another type of the reaction is displacement reaction. Now student, this is the new that I have not explained you prior. Okay. So focus here. Displacement reaction. Now, what happens in this case? Now see students, as the name suggests, I am saying displacement reaction. So displace means when you take the place of someone, or when you remove someone from its place, that it is called displace. Okay. So in this type of reaction, displacement reaction, such thing only occur according to the name. When you will see the things according to the name, half of the idea you will get like this only. So what we come to know? We come to know that in displacement reaction, what happens that it has taken the place of something and something is displaced. So what it is? See now. For this reaction, displacement reaction, what happens, student, that it takes place between the element and compound. What I am saying? Such type of reaction takes place between an element and a compound. So, what happens in this case, that we take one element and another we have taken compound. How? Let's see. Suppose we have X as an element and Y and Z as a compound. Okay, I have taken X as an element and Y and Z as a compound. This is element and this is compound. Now see, whenever we say, see element, it is a metal and this Y and Z is a compound. So whenever compound is there, it is always, this is positive and this is negative. Because when the arrangement for forming a compound takes place, it takes place like this. That prior the positive charge come and then by following it the negative charge come. Okay. So here we can see that for we have taken an element, it is also because it is a metal and you know that metal is positive charge. So this is also a positive charge element. Here this is YZ is a compound. So this compound, this is positive charge, this is negative charge. Okay. Now for carrying out the displacement reaction, what we have to keep in our mind that here this X wants to displace this Y. This X wants to displace this Y and it wants to form a compound with Z. Okay, this X wants to displace Y and want to form the compound with Z. What I am trying to say here, that this X will combine with this Z and this Y will be displaced. This Y will be displaced. Okay, this happens in a displacement reaction. But from here, one thing that I want to say to you, and you have to keep this in mind, that the element which is going to displace element from the compound, the element which is going to displace the element from compound should be more reactive. But what I am saying here, that जब ये डिस्प्लेसमेंट हो तो डिस्प्लेसमेंट के टाइम पे जो एलिमेंट कंपाउंड के एलिमेंट को डिस्प्लेस करना चाहता है, लाइक दिस X want to displace this Y, then the condition that is required, the important condition that is required is that this X, this element must be more reactive than this Y. Either it will not be able to displace Y. अगर इसकी रिएक्टिविटी ज्यादा नहीं होगी Y के कंपैरिजन में, तो ये Y को डिस्प्लेस नहीं कर सकता. This you have to remember. Now see, as I told you, this is element, this is compound. In compound arrangement is like this is positive, this is negative, this is element. Now here let's see how the product will form. So when product will form, this gel will go and combine with this X will go and combine with Z. Okay, this X will go and combine with Z and it forms like X Z plus Y. It will come like this, X Z plus Y. Now what is this X Z plus Y? Then this X is a more reactive element, so it has taken this Z with it, or it has displaced Y and taken the place of Y. In this way also you can see. So this is our displacement reaction. किसको displace कर दिया? This X has displaced this Y. This X has displaced this Y and it has formed the compound with Z, and this is our displacement reaction, and this is our displacement reaction. Now this is the compound and element is displaced. Now this is the compound and element is displaced. So in this way reaction takes place in displacement reaction. Now this is the example. Now as I told you that you have to keep in mind that the matter that is going to displace must be more reactive. So how you will come to know that which metal is more reactive and which one is least reactive? So student, for that there is a metal reactivity series. There is a metal reactivity series that I am going to tell you right now. But before that, let me tell you that this metal series may vary in some books, because that I am going to tell you is the most common, and but when you will see your books, might be there are somewhere metals are more added, right? So don't think that any reactivity series is correct or anyone is wrong. No, somewhere the more metals are added, somewhere only the basic metals are given. So here I am going to tell about the basic metal reactivity series. Now what is the role of this reactivity series? So for that, see, I am going to tell you. Here I am going to write the reactivity series of metals. Okay. For this, what happens that we arrange metals according to their reactivity, and the metals which are on top, they are more reactive, and the metal which comes down, they are least reactive. Okay. So let's see here. Reactivity series. What happens in case of this reactivity series? See, now see, here I have written some metals. Okay, here I have written some metals. Now here see, what is this? Potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold and platinum. Okay, again see, here I have arranged metals according to their reactivity. What are these? Potassium, sodium, calcium, magnesium, aluminium, then this is carbon, this is carbon, and then zinc, iron, tin, lead, then hydrogen, then copper, silver, gold and platinum. See now student, this is the reactivity series. Here, from here we can say that these are more reactive, these are least reactive. Now when the metal, see here I have arranged the reactivity series. In this reactivity series, metals I have written. So the upside here they are more reactive. As we move down, the metals are least reactive, and you have to keep in mind the metal which is on the top can replace the metal which is arranged downside. Okay, जो metal reactivity series में ऊपर है, it can displace all the metals which are written in downside. First thing you have to notice this. Another thing is that, as I told you, this is the metal reactivity series. So I have written metal students, but here you can see that I have written carbon as well as I have written hydrogen. So carbon and hydrogen are not metals. Then why I have written here? See, these are the marking lines. These are the marking lines, means the metals which are above the carbon, they can displace the carbon, but the metals which are below the carbon cannot displace carbon. Okay, And in the same way, the matters which are upside of the hydrogen, they can displace the hydrogen. But the matters which are below side the hydrogen, they cannot displace hydrogen. One thing. Another thing is that even carbon and hydrogen both are non-metal. Even then we have taken them in the activity series. So that at the time of reaction, many times we will have to react with the carbon as well as the hydrogen compounds. Okay. So that's why when we are mentioning this reactivity series, we just put one marking line related to the carbon as well as the hydrogen. Okay. So I hope it is clear to everyone that this is the reactivity series, and this reactivity series decides that which metal can replace which one. Okay. So with the help of this reactivity series, we can carry out the displacement reactions easily. Let's see how. For example, suppose we have zinc plus copper sulfate. Suppose we have to react zinc with copper sulfate. Okay. Now see here everyone carefully. This zinc is an element and this copper sulfate is a compound. Right? This zinc is an element and copper sulfate is a compound. And we have to carry out the displacement reaction. So, I told you that element will displace the metal from the compound and it will take its place. Yes. You know this is positive, this is negative, this is positive. Okay, no problem. Now, at the time of displacement, we have to check that where is zinc in the reactivity series. So, zinc is here. Okay, and when we say copper is here. So, now I hope after going through this reactivity series, it is clear to you that copper is less reactive as compared to zinc. Right? Copper is less reactive as compared to zinc. So, we can very easily displace copper from zinc. Now, it becomes very easy because see where is zinc and where is copper. And I told you these are more reactive and when we move downside, these are least reactive. So, when zinc reacts with sulfur, it forms ZnSO4 plus copper is replaced. So what is this? This type of a reaction is called displacement reaction. Such types of reaction is called displacement reaction. Zinc has reacted with copper sulfate and get changes into ZnSO4. Similarly, suppose we have magnesium plus copper sulfate. Now what do you think? That magnesium will able to displace copper from the compound or not? So for this again we will go through the series, and when we have checked the series, so what we noticed here, that here is the magnesium and here again copper, and now we can see very clearly that magnesium is more reactive as compared to copper. So again what we can do here, we can replace copper by magnesium. So it becomes very easy, and the same way the formula will become MgSO4 plus copper. So what is this? Such type of reactions are called displacement reaction, where the more reactive element can displace the less reactive metal from the compound and forms compound with another one, and the less reactive metals get displaced. Right? This is our displacement reaction. One more, we can the same reaction you can carry with the iron also. You can see here iron is here, copper is here. Okay, so again iron is more reactive as compared to copper. So iron very easily can replace copper. Okay, so such type of reaction takes place, and these reactions are called displacement reaction. Okay. Now students, as we have discussed about the displacement reaction, now I hope that you all have heard about the another type of reaction, that is called double displacement. So when we add double word here In the place of displacement, suppose I am adding double displacement. Okay. In the place of displacement, when it comes double displacement, then what happens? Now see, about the displacement you all know. So what happens in case of double displacement? See beta, in double displacement what happens that compounds are reactant, two compounds are there and they are reacting with each other and they are doing exchange of their ions mutually. Exchange of ions mutually means both the reactants are exchanging their ions together. It is not like that one has exchanged and another is replaced. No. Exchange takes place mutually means both the reactants exchange their ions. For example, see, suppose I have A, B plus C, D. Okay, A, B plus C, D. In this way the compound is there. As I told you, for compound the first one is positive, the another one is negative. The first one is positive, the another one is negative. Now what do you think how this double displacement will take place? So it is so simple here. For carrying out the double displacement, I told you that both exchange their ions mutually. So how they will exchange? See, this A will combine with this D and this B will combine with this C, and the how product will form? See, A and D, it will form like AD plus it will form like CB. It will form like CB. Okay. Why CB? Because C is positive and B is negative. And for forming compound, we are putting positive charge first followed by the negative one. So in this way the product form. In this way the product form. I hope it is clear to everyone. In double displacement reaction, we have two reactants and these two reactants, these two compounds do mutual exchange of ions, and after mutual exchange of ions they form the product, and in product also the compound is there. One thing. Another thing is that when you are forming the product, you have to keep this in mind that this element will combine with this one. Means here positive one will combine with here negative one part, and here negative one will combine with here positive one part, and when the product will form, you will arrange it like positive negative positive negative. Okay, because compound forms like this only. So this is the method of carrying out double displacement reaction. Now student, when we talk about the double displacement reaction, so it's time to see its examples. Let's see. Suppose we have one reaction is common that you all have done previously in activity, and it is, suppose we have lead chloride and barium iodide. Lead chloride and barium iodide. So when lead chloride and barium iodide combine with each other, what happens? This is also positive. This is positive. This is negative. This is positive. This is negative. So here both are the compound, and now here will take place the double displacement. And for double displacement, what will happen? That they will exchange the ions. Positive one will go with the negative one, and here positive one will go with the negative one, and the compound formed is PbI2, PbI2 plus BaCl2 plus BaCl2, which is called lead iodide and barium chloride, which is called lead iodide and barium chloride. And you can see the arrangement. It is like positive negative positive negative, as I told you earlier. So in this way the reaction took place here. And another important thing is that this PbI2 is a PPT, yellow color precipitate form. This I have told you when I explained you the activity in previous video. So when we combine lead chloride with barium iodide, the yellow color PPT is formed, which is lead iodide. Okay, from here, now student, I want to make you clear another thing, that whenever double displacement reaction takes place, there are the two conditions. What? Either the product formed will be PPT or it will form a neutralization reaction. Neutralization reaction means either it will have PPT or PPT means the insoluble substance will form, or a neutral. Neutralization will take place and neutral substance will form. Neutral substance means, as this reaction is a double displacement reaction, so here you have seen that PPT is formed. In the same way, suppose we have sodium chloride. Suppose I have taken hydrogen chloride and sodium hydroxide. Suppose I have HCl plus NaOH. What it is? HCl is an acid and NaOH is a base. Okay, HCl is an acid and NaOH is a base. Now, double displacement will take place here. How it will take place? Again, you know, this is positive, this is negative, this is positive, this is negative. So, this positive will combine with this negative and this positive will combine with this negative, and the product will form this NaCl plus H2O. What is this NaCl? NaCl is a salt. NaCl is a salt and H2O is a water, and this is called neutralization reaction because the thing that we have taken, this is our acid and this is our base. So when we combine acid and base, it forms the neutralization reaction and the product formed is salt and water. So students, today what we learned that in double displacement reaction, when double displacement reaction occur, it forms then the possibility of product is of two types. Either the product is in a PPT form or it will form a salt. Means the neutralization reaction will take place. So for this about the PPT I have shown you one example here, and about the neutralization I have shown you here. Okay. So here we have also discussed about the double displacement reaction. So students, today we have discussed about the four type of reaction. What are these? Combination, decomposition, displacement and double displacement. Now another type of an important reaction, that is redox reaction, is there, the fifth type. But student, I think that we must discuss this fifth type of reaction in another video, so that the content must not become bulky for you. Okay. So I hope the things that I have taught in today's class will be clear to you and you all will able to understand topics. Okay. I hope you all will like this video. Thank you and have a nice day ahead.